Good afternoon friends. Today we will try to learn material balance with chemical reaction. In last video you have seen the material balance without chemical reaction. In that we have learned the distillation, evaporation and extraction operation. There was no involvement of the chemical reaction, but whenever chemical reaction is there, so it is very important to find out the exact balancing of the equation or reaction to get the final product. Now, starting with the stoichiometric equation, suppose we are having the reaction CO plus twice H2 that gives CH2OH. Okay. Now, the stoichiometric equation are nothing but the equation which are in balance with the reactant and product in terms of the moles. So, moles of reactant and product takes part in the reaction, that is nothing but the stoichiometric equation or reaction in terms of in a balanced condition. Now, stoichiometric coefficients. Stoichiometric coefficients are the coefficient that proceeds with this equation or reaction. Now, in this reaction, as you can see, CO having suffix 1, so its stoichiometric coefficient is 1. H2O having coefficient is 2, so I have written the stoichiometric coefficient for H2 is 2. So, these are nothing but the stoichiometric coefficient which will come with the component basically. Stoichiometric ratio. This is nothing but the ratio of two molecular species in balance. So, two molecular species CO and H2 they are in balance. So, their ratio 2:1. This is nothing but the stoichiometric ratio. So, stoichiometric reaction, stoichiometric coefficient and stoichiometric ratio are simple but most important factor when we are trying to balance the reaction. Then talking about the next important concept about the material balance involving chemical reaction is limiting reactant. So, what is limiting reactant? Basically, which will disappear first. Suppose we are having reaction A plus B that gives C, and suppose B disappears first. So, B will be my limiting reactant, which will decide what extent my reaction will proceed. Okay, and this will be lesser as compared to A in terms of stoichiometric proportion. So, which will decide the rate at which the reaction will proceed, extent of the reaction will proceed, which will disappear first, that is nothing but the limiting reactant. For example, C2H4 plus oxygen that gives C2H4O. Now, ethylene oxide is produced. Always remember, whenever we are carrying out the reaction with O, then oxidation, in that reaction generally you will find oxygen or air are always the excess of the reactant. And another reactant will be the limiting reactant. Now, in this case, the excess of reactant which will be more amount as compared to the stoichiometric proportion, that is O2, that is the excess of the reactant. Now, percent excess, the formula we can write for A plus B that gives C. Percent excess of B, as I told you, B is the excess of the component is equal to moles of B supplied minus moles of B theoretically required divided by the moles of B theoretically required into 100. So, theoretically required as per the reaction balance we will get, and actual supplied is nothing but the whatever we have actual supplied, but theoretical as per the reaction. So, that is the difference between the supplied and the theoretical. Now, next important concept is conversion. Conversion is very important factor for any chemical reaction. Mostly we are dealing with the conversion and yield. So, what is conversion? Moles of A reacted. Fine. Moles of A reacted. Suppose this is a reaction. Moles of A reacted divided by moles of A fed. Total moles of A fed is nothing but the moles of A fed, and whatever out of that, whatever the moles of A reacted are nothing but the mole of A reacted that we have taken at numerator, and total moles of A supplied, that is denominator. So, moles of A reacted upon moles of A fed into 100, that is nothing but the conversion. So, higher the conversion means what? Number of mole reacted are more basically. Next important thing is yield. For any chemical reaction, as I told you, we want greater yield and greater conversion. So, what is yield? Slight difference in the formula between conversion and yield. Moles of A reacted to produce C. See this reaction. Moles of A reacted to produce C. Suppose C is my desired product, C is my required product. So, whatever moles of A consumed to produce the desired product divided by moles of A totally reacted. We are saying that moles of A reacted, but important thing is that whatever moles of A reacted to produce my desired product divided by moles of A reacted into 100, it is nothing but the yield. So, you must understand the difference between conversion and yield. Conversion related to A reacted, but yield reacted to whatever the desired amount of component is formed by reacting the one of the most important component, that is A. Okay, so I hope you will understand the limiting reactant, excess of reactant, as well as the stoichiometric ratio and stoichiometric coefficient. Thank you. Please, if you like, please subscribe my video. Thank you.